Hello students, myself Professor Ashok M Jain. In this lecture, I am going to talk about regulation of transformer. We'll discuss how to find the regulation, what is the meaning of regulation, what is the condition of for minimum or zero regulation, and what is the condition for maximum regulation. Okay, so here we'll discuss what is a regulation, what regulation means. Since we know, suppose I have one transformer. So you have one transformer, say R1, X1 is the primary resistance, like that. Clear? On the secondary side, R2, X2 is there, and this is the clear. So what is the meaning of regulation? Regulation means when you connect the load on the secondary side. Okay, so the terminal voltage will change from no load to full load, right? And as the terminal voltage will change from no load to full load at the terminal here due to the change of load. So this change is called as regulation. This change shows the regulation. So इस regulation में terminal voltage change हो रहा है because of what? Because of only this I2 R2 and I2 X2, or this will also be involved. Yes, this will also be involved. क्योंकि अगर load बढ़ाएंगे तो I2 बढ़ेगा, और I2 बढ़ेगा तो obviously I1 will increase. I1 will increase, so V1 is constant, but E1 will decrease. Because E1 equal to क्या होता है V1 minus this drop. E1 will decrease, so obviously E2 will decrease because the ratio is fixed. E2 will decrease, so obviously V2 will decrease. So for the regulation, both this and this will be involved. So in place of that, I am going to transform the primary resistance towards the secondary side. So I can say this is the primary, right? We are applying the voltage V1. The EMF induced here is E1. Clear? Or here, this is the secondary terminal voltage is E2. E2, that is the generated voltage on the secondary side. Or here, these are the resistance and reactance on the secondary, that is R02 and X02. And this is the terminal voltage V2. Now, clear? So we know as load increases, क्या होगा? लोड बढ़ाएंगे तो यहाँ you can connect the load here. As we know, we increase the load current increases, मतलब I2 will increase, right? And when the I2 will increase, the voltage drop in the winding will increase. This voltage drop in the winding will increase. These drops in winding is represented by voltage regulation. Voltage regulation का मतलब है more the regulation means more the drops. For good transformer, regulation should be low, and it should be less than plus minus, less than, it is plus or minus, sorry, it is plus or minus, clear, 5%. So it should be less than 5, plus minus 5%, as per Indian standard rule. Okay, it should be, regulation should be less than 5, plus minus 5%. It may be plus, it may be minus also. Clear? So we'll discuss why, how it is possible. So we can say, what is a voltage regulation? It is defined as a change in secondary terminal voltage from no load to full load at given power factor when primary voltage is kept constant. That is a condition we have. Primary voltage constant रखना है. अगर आपका primary voltage change होगा तो E1 will change. Obviously E2 will change. V2 will change. So no. Regulation का मतलब है only due to the change of load. So we have to keep it constant. So percentage regulation equal to what? V2 at no load minus V2 at load upon V2 at no load. Or you can say it is V2 at no load. No load. Now no load पे V2 और E2 will be same or different? It is same, because लोड नहीं है तो I2 क्या होगा? जीरो. और I2 अगर जीरो है तो V2 और E2 will be same, ड्रॉप ही नहीं होंगे. So V2 at no load equal to E2, और V2 load means full load सेकेंडरी वोल्टेज, राइट। सो परसेंटेज रेगुलेशन का क्या होगा, V2 एट नो लोड मतलब E2 है, E2 माइनस V2 अपॉन E2 into 100. So this is the formula we have for regulation. So how will you define regulation? It is the change in secondary terminal voltage from no load to full load. No load voltage means the E2 minus V2 upon E2 into 100. This is the formula. अच्छा, now जो E2 minus V2 है वो क्या है? This E2 minus V2 क्या है? It is a drop. It shows the drop only. Regulation shows the drop in the winding. Okay, so that is the way of finding the voltage regulation. It should be less than plus or minus 5%. For a good transformer, regulation should be low. जितनी regulation कम होगी उतना अच्छा transformer कहलाएगा, right? Now, how to find the regulation for different types of load condition we are going to discuss. Okay, so I am going to discuss. I am going to draw the vector diagram also. So here we'll discuss how to find the regulation. So you can find the voltage regulation. Okay, we have three conditions. You can find the voltage regulation. This is the secondary side. I'm not going to discuss the primary side. This is E1. This is the secondary side. E2. And here it is winding resistance R02, X02. This is the switch we have, and you can connect the load here. If load is 0, this is the terminal voltage V2. So what is the voltage regulation? It is the secondary terminal voltage V2 at no load minus V2 at load upon V2 at no load condition into multiply by 100. It is called as percentage regulation. So V2 at no load, I2 कितना होगा? 0. I2 will be 0 at no load. So अगर 0 है तो ड्रॉप कितना होगा? 0. So V2 और E2 will be same. So इसको मॉडिफाई करके लिख सकते हैं आप E2 माइनस V2 लोड होगा तो क्या होगा? As you close the load, clear? So I2 will increase. जैसे जैसे लोड बढ़ाते जाएंगे I2 will increase, so drop will increase. So this is the V2 at load condition upon V2 at no load मतलब that is the E2 into 100. That is the formula for regulation. Now, regulation can be affected by nature of power factor. Okay, it depends on the value of load also. It depends on the nature of power factor. So case number 1, I am going to take lagging power factor load. लैगिंग पावर फैक्टर लोड, इसका मतलब है आपका लोड का नेचर क्या है? लैगिंग. लैगिंग का कब होता है? जब इंडक्टिव लोड हो, आरएल लोड हो. You have a load means transformer is a load, suppose induction motor, right? Tube light, fan, clear na? So all these loads are the inductive load. RL load is there. Fridge, washing machine, all are inductive load. Purely resistive load क्या होता है? Heater and geyser and incandescent lamp. क्लियर. लीडिंग पावर फैक्टर लोड क्या होता है? जब आपका कैपेसिटर लोड हो, कैपेसिटिव लोड, आरसी लोड हो, उसको लीडिंग पावर फैक्टर होता है. एनीवे, पावर फैक्टर लोड इंडक्टिव है, लैगिंग. इसका मतलब इफ यू ड्रा द वेक्टर डायग्राम, तो वेक्टर डायग्राम कैसे आएगा? आई एम टेकिंग V एज ए रेफरेंस, राइट? दिस इज द V. This is the voltage V. I am taking V2 as a reference. What about the I2? I2 कहाँ रहेगा? Load, lagging power factor load है तो I2 will lag here, right? So this is I2, and this current is lagging by angle of phi 2. I am assuming current, it is a inductive load means lagging load, RL load is there, so current is lagging to voltage by angle of phi 2, right? Now when this I2 is flowing through the resistance, right, when this current is flowing through the resistance, voltage drop क्या होगा, I2R02, I2R02 कहाँ रहेगा, it is a voltage drop in pure resistance, I into R क्या होता है, voltage drop, so in pure resistance मतलब it will be added in the voltage only, here only, but it is in the same phase with the current, क्योंकि in case of purely resistive circuit, voltage and current are in the same phase, so I2R02 कहाँ रहेगा, in same phase with the current means parallel to the current here, clear? Sorry, so this is what I2, sorry, मैं एक काम करता हूँ, I'm rubbing it, I'm just changing the ink. So I2R02 is a voltage drop in parallel with the current. So this is the voltage parallel, right? So this is the voltage drop क्या होगा, I2R02, and this angle क्या होगा, ये angle phi 2, ये जो phi 2 है तो phi 2. Now I2x, whenever this current I2 flowing through inductive reactance I2x02 voltage drop is there, and we know in case of purely inductive circuit this voltage leads the, because it is a voltage drop in purely inductive circuit, so this voltage will lead to the current, our current will lag, so voltage will lead by angle of what, 90 degree, it's a 90 degree. Okay, so this is what I2, this will be I2 X02 or I2R02 plus I2X02, and sum of these three, this plus this drop equal to E2, so equal to E2. So E2 I am going to draw here. Okay, so this is E2. So how will you write E2 equal to, you can write E2 equal to what, मैं ये मान के चल रहा हूँ ये एंगल negligible है, this and this is same, so can we say this V2 और E2 का एंगल 0, so V2 equal to, can we say V2 प्लस इसका हॉरिजॉन्टल कंपोनेंट क्या होगा, I2R02 का I2R02, हॉरिजॉन्टल कंपोनेंट क्या होगा, cos of phi 2. सिमिलरली I2X02 का हॉरिजॉन्टल कंपोनेंट क्या होगा, इसका हॉरिजॉन्टल कंपोनेंट I2X02 sin phi 2. भाई एक cos phi 2 है तो दूसरा sin phi 2 आएगा, बिकॉज दिस इज परपेंडिकुलर, और आप चाहो तो कर सकते हो, इसका हॉरिजॉन्टल कंपोनेंट cos phi 2 है, इसको आप चाहो तो ऐसा कर सकते हो, चाहो तो इसको एक्सटेंड किया, ये हॉरिजॉन्टल कंपोनेंट, ये एंगल कितना है phi 2, तो ये एंगल कितना है 90 माइनस phi 2 ना, अभी इसको हम बोलते हैं, इसका हॉरिजॉन्टल कंपोनेंट क्या होगा cos phi 2, इसका हॉरिजॉन्टल कंपोनेंट क्या होगा I2X02 cos 90 minus phi 2, cos 90 minus phi 2 is sin phi 2. Okay, this is the E2 equal to this, so E2 minus V2 equal to क्या आएगा, I2 कॉमन ले लिया तो R02 cos phi 2 plus X02 sin phi 2. Okay, and percentage regulation equal to what, E2 minus V2 equal to this upon E2. So this is I2 R02 cos phi 2 plus X02 sin phi 2, और I2 हमने कॉमन ले लिया है, अब चाहो तो I2 R02 ओके अपॉन E2. So this is the multiply by 100, you can say multiply by 100 कर दोगे तो क्या आएगा, it is what percentage regulation. This is the formula we have already used earlier, क्लियर ना. अभी अगर हम इसको थोड़ा सा मॉडिफाई कर दें, परसेंटेज R इक्वल टू व्हाट, I2R02 अपॉन E2 इंटू 100 कर दोगे तो इसको क्या बोलेंगे, ओहमिक लॉस, परसेंटेज R लॉस. Similarly सॉरी इसको क्या बोलते हैं, परसेंटेज ओमिक लॉस। सिमिलरली I2X02 अपॉन E2 इंटू 100 करोगे तो परसेंटेज ओम रिएक्टिव लॉस। ओके, तो इसको क्या कहेंगे, परसेंटेज रेगुलेशन इक्वल टू क्या आएगा, दिस इंटू कॉस फाई प्लस I2X02 upon E2 into 100 percentage reactance into sin phi. So this is the way. So कभी कभी ये दिया रहता है परसेंटेज में 2%, 3%. So 2% दिया तो 0.02 into cos phi लेने का है. Okay, like that. Okay, so we will solve the problem. Okay, so in this way we can solve the problem, right? This is for voltage regulation. You can find by using, यहाँ पर प्लस साइन है, कब है, for lagging power factor load. Now second case I am going to take, load is in capacitive, leading power factor है, तो क्या होगा? Okay, so be careful. This is the formula for lagging power factor, it is plus. अभी मैं लीडिंग के लिए निकालता हूँ, just I am going to rub it first. Case number 2, leading power factor. Case number 2 I am going to discuss. Okay, क्या है, leading power factor, that is RC load, okay, RC load. So I am going to draw the vector diagram for this. Okay, if RC load is there, that is the power factor will be leading. So you can say, you can take V as a reference. Okay, that is the secondary terminal voltage V2 I am taking as a reference. Next is I2. I2 कहाँ रहेगा? I2 will lead, right? I2 will lead to the V2 by angle of, that is I2, and it is leading by angle of phi 2. So this is the leading power factor load. Now drop whenever the current is flowing through the, resistance. So I2 R02 drop is there, right? So कहाँ रहेगा वो drop? Yes, कहाँ रहेगा? I2 R02 will be added. I2 R02 क्या है? Voltage drop. तो voltage vector में add करेंगे, कहाँ रहेगा वो? Parallel with the current, right? So this is what? I2 R02. I2 R02. This angle is phi, parallel to this. Okay, and I2 X02 voltage of current, when the current is flowing through the reactance. So I2 X02 क्या होगा? इसके परपेंडिकुलर आएगा ऐसा. I told you already, reactance will always be more than resistance, right? So I2 X02, this will be more than this resistance, and in तीनों का sum V2 plus this equal to E2. So E2 you will get here. Okay, so this is E2. This is the vector diagram. Now ये एंगल, अगर आपको एंगल ही निकालना है तो ये एंगल क्या है? ये एंगल phi 2 है. तो ये एंगल कितना होगा? 90. तो 90 प्लस phi 2. So दिस एंगल कितना होगा? हॉरिजॉन्टल कंपोनेंट निकालना है तो ये एंगल कितना होगा? 90 माइनस phi 2, राइट ना भाई? दिस एंगल इज phi 2. So this is 90 plus phi 2. यहाँ से 90 plus phi 2. So obviously this will be 90 minus phi 2. Okay, चलो. So क्या लिख सकते हैं? Can we say E2 equal to this voltage? E2 equal to what? E2 equal to V2 plus this V2 plus this, इसका हॉरिजॉन्टल कंपोनेंट क्या होगा? I2 R02, कैपिटल लिख लेते हैं हम, R02. ओके, I2 R02 और इसका हॉरिजॉन्टल कंपोनेंट क्या होगा V2 प्लस इसका हॉरिजॉन्टल कंपोनेंट क्या होगा cos phi 2, क्लियर, प्लस I2 x02 का हॉरिजॉन्टल कंपोनेंट क्या होगा I2 x02 sin phi 2 होगा, राइट। ना इसका हॉरिजॉन्टल कंपोनेंट इधर को जा रहा है, इसका हॉरिजॉन्टल कंपोनेंट कहाँ आएगा, दिस साइड ना, तो ये प्लस होगा कि माइनस, माइनस, और कर लो ना आप। इसका हॉरिजॉन्टल कंपोनेंट क्या होगा I2 x02 cos ऑफ 90 माइनस फाई 2, cos ऑफ 90 माइनस फाई 2 मतलब माइनस फाई 2, 90 minus theta is minus sin theta, so minus this, okay, so E2 minus V2 equal to this, I2 common लिया, R02 cos phi 2 minus X02 sin phi 2 upon E2 into 100 into 100 is called as what, percentage regulation. So you can say same formula we have, but यहाँ पर क्या है leading में minus sign. Be careful about it. So in case of regulation lagging power factor में it is plus sign. In case of leading power factor it is minus because of this component is coming back. इसके opposite में. You can say this is V2 is going here. I2 R02 horizontal component will go here, but this will be opposite. Okay, that's why it is minus. And unity power factor. Unity power factor, please, I'm not going to take the third case. Unity power factor. Unity power factor load, nature of load is unity power factor. Cos phi 2 कितना होगा 1. So phi 2 equal to what 0 degree. तो sin phi 2 क्या होगा 0 हो जाएगा ना भाई, sin 0 is 0. So ये जो टर्म है ये, in case of unity power factor load, this term will be 0. So case 3 में क्या हो जाएगा, only this regulation क्या होगा ये only I2 R02 cos phi कितना है 1 है ना, 1 है upon E2, this term will be 0. क्या lagging okay ना, so this term will be 0. वेक्टर डायग्राम कैसे आएगा, ऐसा आएगा V2 यहाँ, I2 यहाँ, I2 R02 यहाँ और I2 X02 0 है, तो 0 है. So you can, so please be careful about it. Percentage regulation for unity power factor load is this only. Okay, so I'm not going to discuss that much. So this is the way of finding the voltage regulation. This is the formula we have. Clear? Okay. Now next I'm going back. So it is clear what is a voltage regulation, how to find the voltage regulation for lagging power factor load and for leading power factor load. Next I'm going to discuss the next part. I'm going to discuss condition for zero voltage regulation. What is the condition for regulation should be 0? Condition for zero voltage regulation. Okay. So what we have to do? It is very simple. What is the condition for zero voltage regulation? Examiner may ask in oral also, in MCQ also. So first you must know what is the percentage regulation. Okay. So percentage R equal to what formula we have, I2. Yes, what is the formula we have? I'm just rubbing. Okay. Yes, what is the formula we have? Regulation I2 R02 cos phi 2 plus, you can say plus or minus whatever you want, X02 sin phi 2 upon what, E2. That is a formula for percentage regulation, right now? And whenever you are going to calculate the regulation, we have to take the equivalent values of resistance and reactance. Now, you want zero regulation, means numerator should be zero. Zero regulation means what? Numerator term should be zero, right? Now, so this will be zero. So you can say I2 R02 cos phi 2 plus I2 X02 sin phi 2 should be zero. इसका मतलब है I2 R02 cos phi 2 equal to minus I2 X02 sin phi 2, right? I2 will be cancelled. So you this upon this you can say minus 10 sin upon cos क्या होगा minus 10 phi 2, right ना? sin upon cos A equal to क्या होगा माइनस माइनस आएगा ना, ओ सॉरी माइनस तो आ गया, इक्वल टू सॉरी इक्वल टू R02 अपॉन X02. भाई ये टर्म इधर आएगी तो इधर आएगी. सो यू विल गेट फाई इक्वल टू व्हाट, फाई टू एंगल कितना हो चाहिए माइनस, ये माइनस इधर ले लिया माइनस या 10 फाई 2 इक्वल टू माइनस R02 अपॉन X02. So phi 2 equal to what? 10 inverse R02 upon X02 माइनस साइन है. माइनस साइन का मतलब ये जो एंगल आएगा वो निगेटिव आएगा, मतलब नेगेटिव साइन मीन्स लीडिंग पावर फैक्टर. So be careful about it. You will get the zero voltage regulation. Sorry, zero regulation you will get at the leading power factor only. You will get at the leading power factor. Clear? So be careful about it. That is a condition. What is the value of the power factor? 10 inverse R02 upon X02. So leading power factor होना चाहिए, या एंगल जो भी आएगा वो नेगेटिव आएगा. नेगेटिव का मतलब होता है लीडिंग पावर फैक्टर, राइट? So that is a condition. I'm going to take one more thing. I'm going to try it. Okay, just I'm rubbing it. एक चीज जो मैं ड्रा करके बताता हूँ आपको. एक और अगर आप इफ यू ड्रा द रेगुलेशन वर्सेस पावर फैक्टर, सो कैसा ग्राफ आएगा. ओके, जस्ट आई एम गोइंग टू ट्राई इट. Anyway, so this is the graph I'm going to draw. So I'm going to take here I'm going to take the regulation values 1%, 2%, 3%, 4% and 5 plus 5%. I told you already regulation should be less than plus minus 5%. So minus 1%, minus 2, minus 3, minus 4, minus 5%. इसके ऊपर नहीं जाती. क्लियर? दिस इज द लैगिंग पावर फैक्टर लोड है. दिस इज द लैगिंग पावर फैक्टर. और ये कौन सा है? ये कौन सा है? लीडिंग पावर फैक्टर. Okay, I am assuming this is what? This is what? Unity power factor. Okay, then it is 0.8 lagging, 0.6 lagging, 0.4 lagging, 0.2 lagging and 0 lagging. Similarly, this is प्योरली इंडक्टिव लोड है ऐसा, ये 0.8 लीडिंग 0.6 लीडिंग 0.4 लीडिंग 0.2 लीडिंग एंड दिस इज 0 लीडिंग. 0 मतलब प्योरली कैपेसिटिव लोड, राइट? सो इफ यू ड्रा इट इज लाइक दैट, ऐसा कुछ आएगा. एट लीडिंग जीरो पावर फैक्टर कहाँ मिल रहा था, अभी बताया था आपको पिछले प्रेजेंटेशन में. जीरो पावर फैक्टर, दिस इज द पावर फैक्टर, कितना, जीरो ना, रेगुलेशन जीरो है ना इधर, तो यू विल गेट हियर एट लीडिंग पावर फैक्टर, यहाँ कहीं. ओके, और अगर आप इसको ग्राफ को ऐसा करेंगे ना, इट इज लाइक दैट, इसके ऊपर नहीं आएगा, राइट, लाइक दिस. सो दिस इज द कर्व. जैसे जैसे आपका पावर फैक्टर रिड्यूस होगा, योर रेगुलेशन विल इंक्रीज. Clear? Similarly, as you increase the leading power factor, your regulation will increase. But if you want to get the zero regulation, you will get zero regulation at what? Around leading power factor 0.9, more than 0.8. You will get zero power factor. So this is the curve, is very, very important curve we have. It is a regulation versus power factor. Nature of power factor, nature of load. Clear na? So I have drawn it. I'm going back. Okay, and condition for zero voltage regulation tha. Now I'm going to discuss one more condition for one more part. I'm going to discuss. I'm rubbing it first. So these are what I'm going to discuss this for clearing your concept. Your concept must be clear. क्या होता है voltage, अगर power factor change होता है तो how the regulation change, what is the vector diagram, how to draw it. Your concept should be clear, right? So this subject I'm going to discuss for clearing your concept. And one more thing I want to tell you. Suppose you are going to face some interview in some companies. So whenever you are going to face the interview, examiner or interviewer will ask only in machines only. Because suppose करो कि आप एक इंटरव्यू देने जा रहे हैं और वो पावर सपोज करो कि वो जो इंडस्ट्री है वो प्रोटेक्शन की है, स्विच गियर एंड प्रोटेक्शन, so they can ask questions on protection, switch gear and protection. But in general companies they will ask only questions based on the machines. So you have to clear your concept in machines only. अगर आपके machines के clear है concept है, your interview would be good. बिकॉज जो इंटरव्यूअर है, जो इंटरव्यू लेने वाला है, उसको भी मशीन्स के बारे में ही मालूम है, उसको मशीन के बारे में बहुत कुछ नॉलेज नहीं है, एक दो क्वेश्चन मालूम है. ही विल स्टार्ट व्हाट इज द फंक्शन ऑफ द स्टार्टर, लाइक दैट, एंड देन धीरे धीरे ही विल गेट द आंसर्स. ओके, एंड ही विल गेट द क्वेश्चंस आल्सो, कौन कौन सा क्वेश्चन पूछना है. तो योर कंसेप्ट अबाउट ट्रांसफार्मर, योर कंसेप्ट अबाउट डीसी मशीन, इंडक्शन मोटर मस्ट बी क्लियर. Okay, anyway, I'm going to discuss conditions for maximum voltage regulation. Okay, so what is a voltage percentage R? Percentage R क्या होता है? I'm going to, yes, percentage regulation formula क्या है? Sorry, yes, what is percentage regulation formula? Percentage R equal to क्या होता है? I2 R02 cos phi 2 plus X02 sin phi 2 upon E2 into 100. This is the formula for percentage regulation. Now I want maximum voltage regulation. So maximize करना है तो क्या करते हैं? We know, we have studied in some and so many places we have studied. जिस चीज को maximize करना है उसको differentiate करो. Differentiate the percentage regulation. with respect to what? Variable term. What is the variable term here? Phase angle phi. This is the phase angle phi, because we are changing the power factor, right? Load, nature of load, and equal to what? 0. So we are differentiating. So we are differentiating with respect to phi 2, this regulation. So I am going to differentiate this. क्या है? I2 R02 upon E2 cos phi 2 plus I2 X02, I2 into X02 upon E2 into sin phi 2. इसको डिफरेंशिएट करने वाले हैं. फॉरगेट इट द परसेंटेज रेगुलेशन. ओके, सो डिफरेंशिएट करेंगे तो क्या आएगा? एन इक्वल टू व्हाट? इक्वल टू व्हाट? 0. चलो, जब डिफरेंशिएट करेंगे तो क्या आएगा? सो I2 R02 अपॉन E2 कांस्टेंट है, राइट? डिफरेंशिएशन ऑफ cos ऑफ phi 2 विथ रिस्पेक्ट टू phi 2 क्या होगा? sin phi 2. Differentiation will be negative, minus sin phi 2, okay, plus I2 X02 upon E2, right? और differentiation of sin phi 2 क्या होगा? cos phi 2 plus ही रहेगा, equal to 0. So you this equal to this is negative, वहां जाएगा तो you will get I2 R0 upon E2 sin phi 2, ये प्लस हो जाएगा और equal to this I2 X02 upon E2 cos phi 2. Both will be plus. So I2 will be cancelled both side, E2 will be cancelled both side. You will get sin phi 2 upon cos phi 2 क्या आएगा? Sin phi 2 upon cos phi 2 इक्वल टू क्या होता है? tan phi 2 इक्वल टू क्या आएगा? दिस इक्वल टू X02 upon R02. So you will get the phi 2, the angle equal to tan inverse. That is the condition I am getting, tan phi 2 equal to this. So tan inverse X02 upon R02. So you will get the angle. Clear? So you will get the maximum voltage regulation by this, at this particular angle. By you can find this angle, or you can find tan phi 2 equal to this formula. You will get the maximum voltage regulation. So I had taken what is the definition of voltage regulation, how to find the voltage regulation for three cases: lagging, leading, and unity power factor load. Then what is the condition for zero power factor? Zero lagging, zero regulation, and what is the condition for maximum voltage regulation. So I had taken all these cases. Okay, you can get the idea about this, how to find the voltage regulation. Clear? And percentage ohmic and per unit impedance, per unit values, I will solve directly numerical, and I will try to clear your concept there only. Whenever we will solve the numerical, you will get the idea about percentage ohmic loss, percentage reactance drops, okay, and per unit values, how to find the regulation for per unit values, like that. So मैं numerical solve करूंगा वहीं पर ही I will tell you. Okay, so I am stopping here. Okay, and thank you very much for listening me carefully. Thank you.